The bits of paper are attracted to the comb because it is charged with a certain kind of electricity called static electricity. Static electricity is caused by friction, that is, by the rubbing together of certain materials. Electricity that flows in wires is called current electricity. A common dry cell battery produces current electricity by chemical means. The battery in a car produces enough current electricity by chemical means to start the car, run the windshield wipers, operate a dozen or so lights, and run many other electrical things. Very small amounts of current electricity are produced in other ways. Light produces the electricity to move the needle on this photographic exposure meter. The meter needle moves less when there is less light. When there is no light, no electricity is produced, and the needle doesn't move at all. The current electricity that comes into the home is produced by magnets. This kind of electricity is put to many uses. It provides us with light. It's used to run many machines in the home, such as vacuum cleaners, refrigerators, food mixers, and dozens of other machines. Current electricity is used to provide heat, both for cooking and warmth. Electricity is one of the most basic necessities of modern life. The story of this kind of current electricity begins a long time ago, back in the year 1831, when there lived a scientist named Michael Faraday. Faraday's greatest interest was in electricity. A usable kind of electricity had been created in those days by chemical means, but the big, awkward batteries were used only in research laboratories. Scientist Faraday suspected that there was another way of producing electricity. He conducted a simple yet important experiment that proved his suspicion. For his experiment, he used a magnet and a coil of wire. A measuring instrument called a galvanometer was used. The ends of the coil of wire were attached to the galvanometer. As he passed the magnet back and forth through, but without touching the coil of wire, the needle on his galvanometer moved. What caused it to move? Faraday reasoned, and rightfully so, that the magnet had induced an electric current in the wire. His simple apparatus was actually an electrical generator. Most generators in use today are based on the same principle discovered by this pioneer scientist. Faraday's principle is at work in this small electric generator. Instead of one magnet, there are three. Within the magnets, there is a coil of wire. The coil is on a shaft attached to a crank. When the crank is turned, it spins the coil of wire. When the coil is spun next to the magnets, the pull of the magnets, called the magnetic lines of force, cause an electric current to flow in the coil of wire. A meter, similar to Faraday's galvanometer, is attached to the generator and will show the amount of current electricity produced. The electricity thus produced is capable of doing work, such as powering an electric light bulb. Here, man is providing the energy to turn a small generator and produce electricity. But to produce a great amount of electricity, a generator hundreds of times larger is needed, powered by a force much greater than the strength of a man's arm. A generator the size of this one produces enough electricity to meet the needs of thousands of people. Two main kinds of energy are used to run large generators. They are either steam power or the power of falling water. The energy that turns this generator is falling water. An electric plant where water is used as a source of energy is called a hydroelectric plant. The story of producing electricity at a hydroelectric plant begins at the source of the water, often a high mountain lake. By one means or another, the water from the lake is diverted to the hydroelectric plant below. At this lake, large pipes called penstocks are used to carry water from the lake across hills and valleys that lie below the lake, down steep mountain slopes to the power plant below. In this cutaway model of a hydroelectric generator, we can see how water, falling with tremendous force, travels through the penstock and around an adjustable valve which controls the amount of flow. The water strikes the blades of a water wheel, causing it to turn. The water wheel is attached to the generator shaft. When the water wheel turns, the generator turns. This small generator produced current electricity by magnetic means. The force of a man's arm turned the generator. This large generator also produces current electricity by magnetic means. The force of falling water turns the generator. There is enough water falling through the penstocks of this hydroelectric plant to run several generators. The operation of all these generators is carefully watched and regulated at a central control room located within the plant. Surprisingly enough, just a few men are needed to run and oversee the many important functions at a modern hydroelectric plant. Adjustments in generator speeds are made directly from the central control board. Careful notes are kept on how the generators and other pieces of equipment are operating, as shown on dozens of precision meters. Numerous charts automatically record the flow of water through the penstocks, hour by hour throughout the day. Another control board is used to regulate and observe the operation of a smaller hydroelectric plant located many miles away. There need not be a single person on duty at this distant plant, which operates continuously by remote control from the main power plant. Electricity from the hydroelectric plant is sent out through heavy wires. This is high voltage electricity, much more powerful than the electricity used in the home. The electricity travels across mountains and valleys, across hundreds of miles of countryside. Eventually, it reaches a substation in your community. Here, transformers are used to reduce the high voltage electricity to lower power. Other transformers, located on neighborhood power poles, reduce the electricity to the proper voltage for use in the home. Perhaps you'd like to know more about electricity. There are many good books on the subject, and many that tell how to perform interesting experiments. But do remember one thing. If you experiment, for safety's sake, always use dry cell batteries, not the electricity that comes into the home. Simple experiments will prove the principles that we've seen. How static electricity is produced by friction. How current electricity is produced by chemical action. How very small amounts of current electricity are produced by light. and how magnets are used to produce a great amount of electricity for our everyday use.